Right, so we can use relative atomic masses to find the relative masses of molecules and of compounds. Okay, and essentially we just add them all up. So we look at the relative atomic masses of the things involved, and we can work out the relative molecular mass of a particular covalent substance or compound. Okay, so let's have a look at a few simple examples. Hydrogen, for example. Hydrogen is H2, as you know. So, because there are 2 hydrogen atoms per molecule, then the MR, because it's a molecule, it's a molecular mass, so the relative molecular mass, MR, is 2 times 1, 2. No units because it's a relative mass. Okay? So we've just added 1 plus 1 and we've got 2, luckily. Something a little bit more complex, for example, water. Water's got 2 hydrogens and 1 oxygen per molecule. So its relative molecular mass is going to be 2 hydrogens, 2 times 1, plus 1 oxygen, 16, gives me 18. So the relative molecular mass, the MR for water, is 18. Dead easy, no? Just add up the bits that it entails. Relative formula mass, technically we should use for ionic substances. We shouldn't call them relative molecular masses because ionic substances aren't molecules. We can still use the symbol MR. Typically they use the symbol MR, but it's not perfect, but it works. So same plan. Essentially we add up the parts to get the whole. So we look for the relative atomic masses. So sodium chloride, for example, the relative formula mass, MR, of sodium chloride would be 1 sodium ion, 1 chloride ion. So we add them together, 23 for the sodium ion, 35.5 for the chloride, gives me 58.5. So the relative formula mass is 58.5. Now we've said ions, not atoms, but you know that electrons have got a tiny, tiny, tiny mass compared to protons and neutrons. So ions have the same mass as atoms, are considered to have the same mass as atoms, as the mass of the electron is negligible. Negligible means it's so small that it's insignificant. It's not taken into account. Great, so we've done relative atomic masses. We get them from the periodic table. And we can work out relative molecular masses and relative formula masses from those bits of data. Okay, so here's a few practice questions for you. You get the AR for the element at the periodic table and you use the mass number. It's the mass number that you use, the bigger number of the 2 in each of the boxes. So in the case of ammonia, for example, we've got a nitrogen and 3 hydrogens. So I would look at my periodic table. What's the relative atomic mass of nitrogen? 14. Hydrogen, 1. But I've got 3 of them. So 14 plus 3 times 1, 17. You try the other ones. Pause the video a second, and then I'll give you the answers. Okay, methane, CH4 is methane, carbon is 12, hydrogen is 1, so the relative molecular mass of methane is 16. C6H12O6 you might have come across in biology is glucose, so the relative molecular mass is 6 times 12, 6 carbons, 12 times 1, 12 hydrogens, 6 times 16 for oxygen. Add them all together, you get 180. Copper 2 sulfate, copper 64, sulfur 32, oxygen 16, so there's 4 of them. Add it all up, you get 160. Right, this is an introduction to reacting masses, which we'll talk more about later on. But we can use these bits of data, these relative atomic, molecular and formula masses, to work out how much reactant and how much product actually take part in a chemical reaction. Okay, so there are two rules that you must remember here. The first one, the elements always react in the same ratio to form a given compound. So it's a recipe that forms the compound, and it's given by the chemical equation for that particular reaction. So if I'm making carbon dioxide, that's the recipe, that's the formula, that's the equation. The equation is the recipe. Okay? Now if we look at relative atomic and molecular masses, that makes 12 for the carbon, 32 for the oxygen, and 44 for the carbon dioxide. So we can look at this as if they were grams. 12 grams of carbon, 32 grams of oxygen, and they would make 44 grams of carbon dioxide. Now you may have noticed that 12 plus 32 is 44, which is great because that's the law of conservation of mass, isn't it? 12 grams of carbon combines with 32 grams of oxygen to produce 44 grams of carbon dioxide. So we could do a little ratio, a calculation here. You can do this in your head. 6 grams of carbon would combine with 16 grams of oxygen to form how much carbon dioxide? Yes, you guessed it, 22 grams. Okay, we just said this, but basically the total mass of the reactants and the total mass of products has to be the same. So if we look at this example again, obviously 12 plus 32 gives me 44. It's really important. 6 plus 16 gives me 22. The law of conservation of mass. Now we can use this in all reactions. So let's look at the reaction between magnesium and oxygen to form magnesium oxide. And we're going to assume that all the magnesium reacts and try and find out how much oxide will be formed. So if we take 2.4 grams of magnesium, how much oxide will be formed? So we need to write the equation, calculate the relative masses, and use the ratios to calculate the amount of product formed. Again, you can stop the video here for a few minutes if you want to have a try at this, and then we'll look at the answers. Okay, the equation for the reaction is given there. Obviously we need, because the oxygen comes in packets of 2, then obviously we need 2 MgOs on this side, which means we need 2 magnesiums, so we have to put a 2 here. Let's look at the relative masses. We've got 2 magnesiums, so 2 times 24, which is 48. 2 oxygens, 32. And if you do the calculations there, we've got 2 times 24 plus 16, which is 80. Yes, 48 plus 32 equals 80. Good. 48 grams of magnesium would produce 80 grams of magnesium oxide. That's telling me. So 2.4 grams of magnesium would produce, this is where you need to do a little calculation, cross multiplication. I'll let you have a go at that. Essentially, these are proportions and ratios. So the calculation would be 2.4 times 80, all divided by 48, which gives me 4 grams. 2.4 grams of magnesium would produce 4 grams of magnesium oxide. Right, read pages 58 and 59 and try the questions.